Now before I go on and you go on and practice all the knowledge about directional derivatives so that you can really tackle any problem that might come up in the exam and also during the discussion sessions, let's have a look at a couple of properties of the gradient of f, which you will cover in much more detail in, for example, Physics 115, but that you can already do. This is also one of the questions in worksheet 5 for which you have the solutions, but let's go through them. Now in 10.7, in your lecture notes, you'll find a couple of useful properties regarding the gradient of f. And let's just have a look at one of them that is quite easy to show, and it's the sort of question that you should be able to do in an exam. The second property, I'll leave it up to you to go through it. Let me know if you want me to go through it in the discussion or one by one. It is not something you are expected to do on your own, but this one definitely is. First of all, I guess one of the things that's kind of cool to realize is that so far, and from section 8, when you were calculating these partial derivatives, df dx, df dy, or df dz, all you were really doing was calculating the components of the gradient of f. And also that taking this partial derivative is the same as taking a directional derivative along f of x when u has components 1, 0, 0. While the partial derivative in respect to y really is a directional derivative when u has components 0, 1, 0. Same thing for z. You're calculating a directional derivative when u equals 0, 0, 1. What this is telling you is actually partial derivatives are just a very specific, special case of directional derivatives when the unit vector only has components in one of the coordinates. That's it. In a way, once you know directional derivatives, you don't care about partials anymore, although in practice, the way you calculate directional derivatives is by knowing partial derivatives, so don't forget about that. Oh, what the hell happened? We were supposed to be looking at some properties of the gradient vector and it's already the end? No way, no way. Let's go back. That's better. And before we're done with section 10 and actually Physics 111, you already saw a glimpse of the future to come. Physics 111 really is ending. We should have a look, as I told you, about some useful properties of the gradient of f, which you will cover even more in Physics 115, for example, in vector calculus. The gradient of f, which we've seen as components fx, fy, fz. A cool useful property that you can find in section 10.7, which I've called property 1, is that the maximum of a directional derivative along some unit vector in general is essentially given by the modulus of the gradient of f. This is the sort of property that you would be expected to be able to demonstrate in an exam. It's also the first question in the final worksheet. It is not assessed, but you already have access to the solutions and you can check whether you understand them. In this case, it's relatively simple. It's all about writing down what a directional derivative is in terms of the gradient of f. And you can write it, as we've seen, as a dot product of the gradient of f with the unit vector. And this is the same as looking at the modulus of the gradient of f times the modulus of the unit vector times cosine of theta, with theta being the angle between the unit vector and the gradient vector. And you can very easily show that the maximum of the directional derivative, which is this dot product, will be given by this for very simple reasons. One is this by definition is 1. It doesn't really matter. And cosine will be varying between -1 and 1. The maximum that this can have is when cos is +1, and this happens actually when theta is equal to 0. So apart from very easily demonstrating that this is the case by writing the dot product and the fact that the unit vector has a modulus of 1, and therefore the maximum that this quantity can have is when cosine is 1, and then this is the value of the maximum. You can also learn that this is achieved when the angle is 0. What does that mean? Let's say, for example, that the ukulele is the gradient vector, and this is the direction it's pointing, and the marker is the unit vector. The directional derivative of a given surface, that in this case is completely imaginary, and this is a very bad example, but just go along with it. It happens when the unit vector is perfectly aligned with the gradient vector of f, or in this case, the ukulele. In this case, the directional derivative, if this was the way that we were sampling the surface, would give us the highest value. What does that actually mean? Let's think of a simpler, more objective example. Let's say that the surface is the ukulele, okay, and that we're looking specifically at this part over here. We now know how to take directional derivatives. So if this is our unit vector, we can see that if we're taking a directional derivative along it, the directional derivative is actually 0. That's because the gradient is null, essentially. But as we move the unit vector along this direction and aligning with the highest gradient, we'll see that the directional derivative, in this case, is actually going to be quite steep, negative, because we're going that way. But if the unit vector was aligned this way, it would be positive. And all this means is that if you align the unit vector with the place where the surface has the steepest gradient, you're going to get the largest directional derivative. That's all it means. I would also encourage you to have a detailed look at property number 2. It's not something that would be expected from you in an exam, but you should be able to understand the steps. And if there's any question, please just get in touch via Teams or email, or if you want to see it done in a discussion session, I would be more than happy to do it. So it seems like now is actually the time, and it's finally happening. As you can see, we're definitely on another timeline, because this is not exactly the same. If you go back to the beginning of the video, we have changed the universe, hopefully in a positive way, and hopefully by completing Physics 101, you've also changed your own timeline to a way better timeline when you're going to nail any differentiation problem, and you're definitely ready to tackle Physics 112 integration. I will, of course, still see you in discussion sessions, on the feedback sessions, and as I disappear one last time from the contents of Physics 101 with a powerful ukulele, I can tell you that I might be able to come back for maybe 1 or 2 special messages, and hopefully sooner rather than later you'll be able to sit down in real lecture theaters and be taught face to face. Until then, I really hope that you've learned a lot about functions and differentiation, all the way from taking limits to directional derivatives. Remember that you'll be able to access these videos not only for the following weeks, even as you take integration, Physics 112, but also throughout your degree. And remember that you can also ask questions via Teams and email. And the final thing, as always, as for all sections, for all of Physics 101 and for all the modules, don't forget the importance of practicing. And that's it. Let's get the ukulele. Yeah. And because you've endured until the last video of Physics 101, here's your reward, the full Physics 101 ukulele album. No, I'm just joking. There's no album. I was too busy teaching you. For the album, I definitely need to use the ukulele to disappear into the future, practice a lot, and then come back like a pro. Because you do not have a time machine, what you really need to do is practice a lot in the present and be spectacular in the future. So don't forget to practice a lot. And that's it. Physics 101, at least the lecture videos, are done. It's time for me to disappear one last time. Might be able to find another time machine and come back for a special message, but if not, you need to catch me, my past self, in the discussion session. So I'll see you then. Oops. What if I'm stuck here? Well, at least I'll have time to practice, right? And actually learn how to play the ukulele, which I definitely do not, or I will finally find the frequency and disappear. I think that's it. Bye everyone. And that's really the end of Physics 111. See you around.